Hi. So we had a designer come in and he had a proposal for a chair, a very unique looking modern chair. And this was his proposal. But he wanted to know how much volume this chair is going to take up to just figure out, is it feasible? Could anyone actually sit on it? How much space in a room would it take up? So it's our job to find the overall volume of this structure. But I noticed that it's not one shape. So I can't just do length times width times height. I see that it's made up of two different shapes, a smaller rectangular prism up here and a larger one down here. In order to find that overall volume, I'm going to find the volume of each individual structure. So let's look at the volume of this bottom one first. We're going to call it structure A. Okay. Structure A, we know that the volume is going to equal length times width times height. Now let's identify our different components. Notice how I did length times width times height instead of base area times height. I did that because I see three different measurements, meaning that instead of base area, they gave us length and width. Our length is always this front face, so we have 6. Our width is how far deep it goes, so we have 5 inches there. And our height is only the height of this structure, so it's only going to be 4 inches tall. The structure on top has that extra little height to it, but this height of this prism is only 4 inches. And now we multiply. 6 times 5 is 30 times 4. I know 3 times 4 is 12, but it's 30, not 3. So you're not going to have that 0 at the end because every digit gets moved up a place. So the volume of the structure is 120 inches cubed. But that's not the entire volume because we still need to find the volume of this top structure. So let's look. What do I notice about this top structure? I notice that right here, it's giving me the length. It's saying that this one part is 3 inches. So let's look at structure B. We know volume equals length times width times height. We've already found that our length is 3 inches. Our width is not labeled, but it matches the width down here because it goes from this line directly back. They're completely overlapped. One doesn't go out farther or is shorter. So we know that they're the same. So our width is going to be 5. Sorry, there we go. And our height is 2. This smaller structure only has a height of 2. So now let's multiply to find. I know that 5 times 2 is 10. So then I multiply by 3, and I'm going to get 30. So the volume of the smaller rectangular prism on top is 30 inches cubed. Now, I found the volume of this structure, 30, and the volume of this structure, 120. But I want the overall volume. Overall volume. What does the word overall mean? It's similar to another word. It's similar to the word in all. What operation comes to mind when you hear the word in all? Adding. We're looking at the additive property of volume today. So we're adding volumes together. So our overall volume is going to be 120 plus 30, which is going to get me 150. 150 cubic inches. So our designer's chair is 150 cubic inches. You decide if that's going to be big enough for you to sit on.